So this is the threading tool I made last year. There's a build video if you're interested. But today, it's not really about this tool, it's about something else I made at that time, this carriage stop. Actually, let me tell you what happened. My camera died and I had to send it in for repair. So until I get it back, the current project is on hold. And right now, this is the best footage I've got. Now about the carriage stop. I didn't really have to make it. All I needed was a way to trigger the retraction on the threading tool. Something 3D printed would have been enough, but where's the challenge? So these tools were made around the time I got my fiber laser, and one of the very first things I used it for was tracing layout lines. Or maybe I should call them visual references. They're not as accurate as the ones you can trace on a surface plate, but they're really helpful for avoiding mistakes, especially when there are weird angles involved. And by weird angles, I mean the prismatic ways on my lathe. They're not 90 degrees as you might think, they're 94. At least that's what I got from some 3D printed gauges and a quick internet search. The only problem is, they're not actually 94. Angle blocks and some milling, there's not much to it. Or that's what I thought, but after trying it on the lathe, it was clear the angle was wrong. I wish I had the footage to show you, but I can't seem to find it at this point. Anyway, you'll have to take my word for it, the angle was slightly off. And you might think it's not a big deal, but it actually is. So this block clamps onto the bed like this. Sorry about the drawing, I suck at drawing. Dog, cat, bird, and me. Yeah, I didn't get to where I am in life with a pen in my hand. So now you know. So this bottom plate, when it's clamped, forces the block down, and I believe the forces should be around here. And if the angles aren't right, the whole thing will rock. You see a lot of these rock. So to get mine holding onto the bed like this, I had to fix the angles. I started by adding a quarter angle, then one more, and eventually ended up with 47 on one side and 46.5 on the other. That's 93.5 total, uneven sides. It's weird that this is what looks right, but it is what it is. Next, let's make this tool real sexy. The tricky part here was making all the holes without them interfering with each other. The bottom hole is for an 8mm rod, that's the basic hard stop for the carriage. Then there's the top hole, which is for a DTI. I'm not sure if I'll ever need it, since my lathe has a DRO, but better have it if the time comes. The rod and the DTI are held in place with set screws from the back, and both of them touch the saddle, not the painted gearbox. Finally, we have two threaded holes on the top. These are for mounting wherever I might need. In this case, the stop for the threading tool. Speaking of which, I was going to make a simple bracket, but instead I decided to make a square. Like a fixturing square. Something I don't have and that could actually come in handy one day. Better than a dedicated bracket. I used an M8 bolt to join the post to the base of the square, and I also added a couple of pins. I didn't press fit them to make it easier to take the square apart and machine both pieces separately. I ended up making a final pass with the square as one piece, just to try and make it a bit more precise. Then I opened up 2 slots on the post, to clamp it or attach stuff to it. But I wasn't done until I broke 2 end mills making its chamfer. Cheap Chinese ones, pretty bad worn out. But the square turned out better than I expected, and better than what I usually get from my mill. This is a half-thou indicator, so pretty good for something I can reuse for my laser and such. As for the bottom plate, well, I left it for last because I started having second thoughts about it. The initial plan was to machine a step at the back, so the clamp would sit a bit higher there. But the main body was looking too good to machine a recess from side to side. So I tried to hide it. If it were today, I'd do it differently. The sliding type, front to back, it's just easier to mount on the lathe. And this is what I came up with. The advantage of these, compared to my initial plan, is that it keeps the bottom plate in the correct orientation at all times. The downside is that I have to unscrew the locking bolt more than I'd like to, just to remove the stop from the lathe. So after machining this plate and test the fit on the lathe, I realized it was only touching along the front edge. Again, this is another reason why a carriage stop can tilt. To fix it, I machined the bottom block again, this time resting on a 1-degree angle block. Machining the clamp this way allowed more surface to contact the bottom of the bedway. This, right here. And the problem with these is depth. The carriage gear rack takes up most of it, so in reality there's only 7mm left to clamp the tool. What I was trying to explain earlier is that this arrangement is a bit weird. It's not like you have a top and bottom part clamping against each other. The bottom clamp only reaches about halfway along this angled wall, so the tool will always have a tendency to tilt, if the angles aren't perfect. Okay, so after 1 year, I'd say I used this a lot more than I thought I would. A good example was the switch I made for Eric for the tool room takeover video. Every time I needed to make multiples of the same part, I used it. It was a reliable way to avoid overshooting the length of a feature, or to avoid hitting the chuck jaws, for example. Also, it delivers a good level of precision. Another obvious use is to hold the arm that retracts the threading tool. Easy to set up, very repeatable. It was a bit of work, but it was the right choice. What I haven't used so far is the indicator, but hey, it's good to have options. And I think this wraps it up. It's a simple tool, but a useful one. As for my camera, I just got it back, so I hope this time it won't take so long to push out a new video. Until then, go out and make a carriage stop.